Hi, Chem team. So far this year, we've defined covalent bonds as occurring when nonmetals share electrons. But it turns out nonmetals don't always share electrons equally. And we call unequally shared orbitals polar covalent bonds. So for instance, water molecules have polar covalent bonds in them. In order to stabilize, oxygen and hydrogen are two nonmetals that will share unfilled orbitals with each other. However, because oxygen has a higher electronegativity than hydrogen does, you can see oxygen has an electronegativity of 3.5 and hydrogen has an electronegativity of 2.1. The oxygen atom will attract these electrons slightly more strongly than the hydrogens. And as a result, the electrons will move slightly closer to oxygen than they will to hydrogen. Now, this isn't a complete ionic bond. These electrons are still being shared. They haven't completely been stripped away from the hydrogens. However, because the electrons are pulled slightly closer to oxygen, oxygen will have a slightly negative charge to it. And we show that with this Greek symbol meaning partially or slightly. Meanwhile, the hydrogens, because they are ever so slightly losing their electrons in oxygen's direction, the hydrogens become slightly positive. And again, we use this squiggle Greek letter to show that the hydrogens are partially positive. And you'll notice too that we actually use an arrow with a little plus sign attached to it to show the direction that these negative electrons are moving. Where the electrons are moving away from becomes slightly positive, and the direction that the electrons are moving toward becomes slightly negative. So this is a polar covalent bond, where one end of the bond is slightly negative and the other end of the bond is slightly positive. A nonpolar covalent bond occurs when electrons are shared equally. So take, for instance, these two hydrogen atoms. Because each hydrogen has the exact same electronegativity, when these two hydrogen atoms share a valence orbital to stabilize their valence shells, they will attract the electrons equally. They have the same electronegativity, so neither is able to pull the electrons closer to itself. As a result, neither hydrogen becomes more positive or more negative than the other. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.